from Classiq Technologies. I'm sorry, Dr. Naveh is the Chief Technology Officer at Classiq Technologies. And he's also a co-founder there. He earned his bachelor's in physics and mathematics, and he also has a master's degree in experimental physics, as well as a PhD in theoretical quantum physics, all from the Hebrew University of Jerusalem in Israel. And before joining Classiq, Yehuda was a research scientist at Stony Brook University in New York and a research staff member at IBM Research in Haifa in Israel. Dr. Naveh is the co-author of dozens of peer-reviewed research papers, and he's also the co-inventor of more than 15 patents. Welcome, Dr. Naveh. And he has a co-presenter. I'm sorry, go ahead. He has a co-presenter, Mr. Masayoshi Terabe. Mr. Terabe is head of quantum transformation at the Sumitomo Corporation. And he's also associate visiting professor at Tohoku University in Japan. Mr. Terabe received his master's in quantum engineering from Nagoya University in 2007, and he has 13 years of engineering experience at the Denso Corporation. In 2020, he joined the Sumitomo Corporation and launched a new project to create a new business using quantum computing. He had been leading application demonstrations of quantum computing in mobility services, factories, and air mobility control. Without further ado, we'll go ahead and get started with this next segment. Thank you so much to you both. Thank you for accepting my invitation to speak today. Go ahead, please.
Thank you very much, Maeva, for having us here in this exciting symposium. And thank you as well, Jenny, for your wonderful talk and also for addressing my question. My part will be, I'll try to be rather short as I'm the first speaker of the symposium, the first technical speaker in quantum. I will try to orient myself in around 7 to 10 minutes on what is quantum computing in essence, or what are the most important takeaway messages about all this hype on quantum computers, and my colleague Terabe-san will show the practicalities of how one would apply this wonderful technology towards sustainability issues. So what we all recognize is that quantum computing is based on qubits, which obviously rely on the superposition principle, but I will try to, address these notions with a few more details, so we'll be on the same page regarding what is the essence of computing. So maybe from the most theoretical side, or if we take a computer scientist view of quantum computing, the most basic or important thing to think about a quantum computer is its interfaces. And fortunately for us, or possibly you may say by design, the interfaces of quantum computer are exactly the same interfaces as a classical computer. So the inputs and outputs to a quantum computer are just the regular bits, classical bits that you are used to. And this is a most important notion because it allows us to analyze and explore the mathematical notion of quantum computation with classical means. The insides of a quantum computer is, of course, very different, but the outputs, the interfaces, are just as for a classical computer. And when we look at the insides, there are three different notions of the physics of quantum mechanics, which allow us to do computation possibly in a much stronger, mathematically stronger way. First is the superposition principle, which in a sense tells us that in theory, or in general, we can think of a quantum computer as an exponentially large parallelization machines. All for n qubits, all 2 to the n computational paths exist within the computer. Second is the principle of entanglement, which are the weird correlations between quantum particles, which in some sense is the Einstein famous saying that he does not believe that God plays with cubes, is related to these very weird correlations. And third principle is the principle of quantum interference, which sometimes goes by the name of wave-particle duality, which allows us to extract the computational results out of those weird correlations. All three principles, physical principles, go hand in hand inside the quantum computer in order, to show the results or the results on paper that we already know that it is in principle computationally stronger. And the math can be difficult, and of course it is an area, of expertise, but the basics are just what I mentioned. And once you know the math, you don't really need to go into, the philosophical details. People who know how to do the math will be able to compute the quantum computer. And with this in mind, we already know that there are problems, for example, factoring of a number, which are, as far as we know today, maybe hard problems for a classical computer, but easy for a quantum computer. So once we have the quantum computer at hand, we may be able to solve problems that are not known today to be solved on a classical computers. And with this in mind, Terabe-san will try to take this principle of quantum easy problems compared to classical hard problems and try to explore where they exist within the sustainability domain. The issue is that while there are a few, proofs, mathematical proofs, that we are able to solve on a quantum computer problems that in principle cannot be solved today on a classical computer, most of those problems that may exist there that have the same principle of being quantum easy but classical hard are yet not known. And therefore today we need to develop, we need to address very challenging software problems, not only hardware problems, in order to reach out to such complex questions as Terabe-san will show, where we may imagine that there is a quantum easy solution, but we are not yet there in terms of the software. And therefore, much of the activity in the community goes into developing the correct quantum software, regardless of the development of the quantum hardware, which everyone or most are aware about. And the point is that if I compare the quantum hardware to such classical beasts and say that the quantum hardware is better, and this was the theoretical saying, now we should go ahead and explore what software can be run on this quantum beast in order to reach results which are benefit to us. And the place where this is done is throughout, all those companies and many more, where people already today are designating quantum software developers teams to enhance and to build new algorithms and to understand much deeply the quantum software notion or challenge in order to solve the pressing business and societal problems at stake, the problems that may be quantum easy, but classical hard. And having given this very brief introduction to the status of quantum computing today, I will just say 2 words about our company, which actually has a goal or a vision to help all those software developers of quantum algorithms do their work, much more methodologically and much more simply, and with showing the platform of how you can do that with this quantum circuit, I will pass it on to Terabe-san to show some exciting applications in sustainability.
Thanks, Yehuda, and hi, everyone. I'll talk from now. Actually, it's midnight in Japan, so let me say good evening. I'm Masayoshi Terabe, call me Matt. I'm the head of Quantum Transformation Project at Sumitomo Corporation, as Maeva introduced. As a user of quantum computers, I'm working on various application demonstrations. I had been an engineer in the automotive industry for a long time, and I have experience in developing quantum computer applications in the factory and mobility service fields. Last year, I joined Sumitomo Corporation, which has a variety of business fields, and launched the Quantum Transformation Project, which aims to create new value by combining these business fields with quantum computers. I am honored to be able to speak at this symposium today. Thank you very much. And here, let me switch to my screen because I have some movies. Just a moment. And let's start again. Yehuda's talk made us realize how quantum computers are going to have great performance and impact in our future. Now, let's imagine what kind of world quantum computers will create and how they will contribute to sustainability in the world we live in today. The world today has undergone numerous changes due to digital transformation, DX, shifting from analog to digital. I believe that quantum transformation will happen next. This is the origin of the name of our project. So, how exactly will a quantum computer change our society? There are many examples of research in chemistry and finance, etc. However, I believe that optimization will change the world a lot. Let's dig a little deeper. Here's an example with a problem we all have faced: traffic jams. As we all probably have experienced, commuting to work in the morning. On current roads, everyone is self-centered, eager to get to their own destination as quickly as possible. As a result, the dilemma arises that not everyone can reach their destination quickly. This is because everyone gathers on the shortest route to reach their destination quickly. This causes huge traffic jams, and when traffic jams occur, the next shortest route becomes congested. Very stressful, right? On the other hand, let's think about optimizing this traffic as a whole to reduce our stress in the morning. Let's demonstrate my car going from the left, your car from the right, and so on. Everyone chooses a distributed route. As a result, in this example, there are no traffic jams, and we can reach the destination way faster and much happier. This is an everyday example, but if we apply this idea in other aspects of our society and optimize the entire system, we will be able to solve social problems like this as a whole. However, this kind of society cannot be achieved with our current conventional computers. This is because calculating optimization globally is extremely difficult. This kind of optimization problem is called a combinatorial optimization problem. Even with small variables, the number of combinations can be very large. For example, in the problem of eliminating traffic congestion, if each car can choose one of three routes, the problem is to select the combination of routes that causes the least traffic congestion as whole. In this problem, with one car, there are 3 ways, and with 2 cars, there are 9 ways. But with 10 cars, there are roughly 60,000 ways. With 20 cars, there are 3.5 billion ways, and with 30 cars, there are 200 trillion ways. This is a very large number. Of course, the number of cars is much larger than 30 in the real world. So we have to choose from a much larger number of combinations to avoid traffic jams. This calculation cannot be done in real time by conventional computers. It may take several hours or even days. But if a quantum computer could do it in a few minutes, we might be able to control all the cars in the city in real time and eliminate traffic jams. Until now, massive combinatorial optimization has only been in the world of simulation. But if it becomes real time with quantum computers, this will change our society. Quantum computers will not only solve traffic jams. This technology will solve many of our social problems caused by such imbalances. For example, while we are throwing things away, there may be people who want it. Solving this problem will lead to less mass production in factories, eventually lowering CO2 emission. The same goes for the problem of food waste. But you may wonder, can the quantum computer really solve these problems? Actually, no one knows for sure. There are many challenges to be overcome, but we can take up the challenge now. The Quantum Transformation Project aims to create great value by applying quantum computers to all sorts of social problems, from underground to outer space. We would be happy to take on this challenge with you as well. The company I work for, Sumitomo Corporation, is a large conglomerate company with more than 900 consolidated companies. We have a wide range of business fields. We are utilizing these various fields to test out and eventually create a new society I mentioned earlier. Now, let's imagine the world 10 years or more in the future. There will be hundreds of thousands of UAVs, drones that can carry people, flying around in one city. Real-time control to operate these UAVs safely and at high speed will be a challenge. That's where I think quantum computers can be used. This is a Quantum Sky project. For this project, we are collaborating with OneSky, a US startup with high technology in UAV traffic control, and Tohoku University in Japan, which has great quantum computing application technologies. UAV is a general term for drones that carry people to cargo and has various advantages. For example, it moves fast, it is resistant to failure because it works by electrical motor compared to engine, and it eliminates labor shortage in logistics because there's no need for driver. UAVs contribute to sustainability because they travel in the sky with no CO2 emissions and reduce congestion on the ground. This is OneSky's current UAV control system. There is no quantum computation yet. As you can see here, the system controls multiple UAVs safely and efficiently while putting various constraints such as weather on the map. Based on this system, we will be demonstrating the implementation of quantum computing technology. And let's move to next our challenge. Also, have you ever seen this kind of news? The power consumption of AI has increased 300,000 times in 6 years. So AI might burn the planet. Quantum computers are ultra-low power. In the case of D-Wave's quantum annealing machine, the power is very small, 20 femtowatt. That's because it's made of superconductivity. Superconductivity needs to be cool to work, but even including the cryostat to cool it, the power is only 20 kilowatt. If we could replace AI with a quantum computer, we could solve the power consumption problem. To test this out, we are currently demonstrating price prediction in our actual commodity trading business. We have demonstrated price prediction using deep learning on classical computers, but currently accuracy was not good enough. Therefore, if we can realize a new method of AI using quantum computing, we may be able to achieve even greater accuracy. Even if the accuracy is the same, quantum AI will have a huge advantage in terms of power consumption. When it comes to electricity, we are beginning to think about ultra-fast supply and demand adjustment using quantum computers. The demand for renewable energy sources, such as wind and solar, is growing rapidly, but they are very volatile. On days when the wind doesn't blow or it's cloudy, these wind and solar powers doesn't generate electricity. In response to such fluctuations, conventional technologies do not adjust supply and demand quickly enough, resulting in large losses and shortages. If this can be properly adjusted by quantum computers, we will be able to enter an era centered on renewable energy in a better way. We are challenging those problems because we have power plants and electricity retail business globally. These various elements created by quantum computers, such as the one I mentioned earlier, will eventually find their way more and more into cities. We are currently working on a number of smart city projects. For example, we are working on a project to build a smart city covering over 272 hectares in North Hanoi, Vietnam. That's a huge project. If we can put the living lab, which demonstrates quantum technology, into these smart cities, I am sure that new applications will be created that have never existed before. And there are still many challenges to be overcome to realize these futures. For example, we need to find a killer application. To do this, we need to conduct a lot of POCs with various partners. We are still exploring what quantum computers can do, but it is very difficult to implement it in a quantum computer. The reason is that there are not many advanced quantum engineers who can implement quantum circuits and qubit models. However, the tools that Yehuda and his team Classiq are creating will help us greatly. So this is the final chart, and the race to create a new value with quantum computing has already begun. We, Sumitomo Corporation and Classiq, would be very happy to take on this challenge with you as well. Thank you very much for your attention.